Hello, everyone, and welcome to the lecture on Chapter 15 Big Data. So, earlier in this week, or for the lectures for this week, we talked about secondary data. And one of the benefits of secondary data is that you get these really large data sets. And I like to pair Chapter 8 with Chapter 15 because Chapter 15 is all about those large data sets, big data, what we can do and what options are available to us when we're working with these huge data sets. So that's what we're going to be talking about today. So in a very basic form, data as a definition is a form of organized or disorganized information, structured or unstructured information, or even number or textual information that we can use to see what's going on in the world. So, data really varies. It is just information that can come in any form: structured, unstructured, organized, disorganized, numbered, textual, whatever it is information that we can use to draw conclusions about it. So that's data. Big data then is a large collective of information that accumulates very quickly and come in large varieties. So, data is this really broad umbrella term, and big data refers to these large data sets that have a wide collective of information that accumulates incredibly quickly that we can then use to conduct our own studies. And when we're talking about the name of big data, really, big data was coined to describe those very large data sets that are collecting data at an amazing speed and that contains so much information that traditional software cannot handle it properly. And really, I think this is kind of fascinating because what really happened was we had these ways of analyzing data that were pretty standard. Like early on, people could analyze data by hand, but you were limited in that you could only work with small data sets because if you were analyzing data by hand, it was really hard the bigger your data set got. And then once we started getting simple analyses programs on computers, we got a little bit more variety and a little bit more variation, but you're still limited. And then we saw this huge technology boom. As technology got more advanced, data sets got even bigger because there was just so much information out there that could be collected. And all of a sudden, traditional software just couldn't keep up, which is really fascinating. And the field of big data really exploded with the internet's ability to accumulate information and the widespread use of social media. With that sort of explosion, data was now coming at a faster speed, at larger volumes, and was in various structures. And this surge of data and information founded the new discipline of data science that focuses on how to handle, clean, and analyze these large amounts of data. So, big data really came out of this technology boom in our society and really opened the world for this entire new data science discipline. And when we're talking about the vastness of big data, we oftentimes describe it as the three V's of big data, which are the characteristics used to determine if data can be considered big data. The first of the three V's is the volume, which refers to the amount of information that has been collected. Big data has reached an extraordinary extent. So we say that if data can be considered big data, it has to be larger than a certain amount. And you'll notice that I'm being pretty vague here because big data in one context is not necessarily big data in another context. So a good example of this is big data in social media might mean that you have a data set with over 250,000 participants. But big data in terms of cannabis users might be something like 50,000. Like they are just different barometers of what volume looks like, which is why we have multiple V's of big data. So the second V of big data refers to velocity, which is the speed with which information is collected, accumulated, and moves across the world. When information is collected rapidly, it can be accumulated fast and it can be distributed widely in a very short amount of time. We say that it has velocity, and that is one of the characteristics of big data. And finally, the last V refers to variety, which is the fact that big data does not have a specific structure and shape. It can consist of images, text, numbers, any type of data. But that is one of the key characteristics of big data, is that you have this wide range of what is available to you in terms of the type of information that has been gathered. So there are different types of big data, and we really use these types to just break down and provide a little bit of understanding of the variety of big data. So one example of a type of big data is called structured data, which is data that is highly organized and into tables, and each of those tables relate to each other with a relational key. So the key characteristic of structured big data is that there is a relational key that makes it so that you can draw comparisons across different tables, because there's a relational key that says, okay, this is how this data set is related to this one. The way that I like to think about this is if your relational key was the unique participant identifier for each person in your data set. You might be collecting data from that person multiple times, or you might have them sit for 6 hours and collect data from them in different areas. But because you have a unique identifier, you can say, okay, here was this person's data in terms of their substance use. Here was their data in terms of their sexual behavior. Here's their data in terms of what type of food they eat. And each of those can be distributed into their own tables. But you have this unique relational key that makes it so that the data is structured and can be organized across those tables. And that's the unique thing about structured data, is that relational key that makes the data highly organized and easy to draw those comparisons. We also have semi-structured data, which is data that has organization in a hierarchical order, but is not relational in nature. So the most common type of semi-structured data is collected by organizations and companies. So this is information where it has an organization or it has a hierarchy, in the sense that here's all the data that were collected by managers. Here's all the data that are collected from the entry-level employees. Here's all the data that are collected by the supervisors or whatever. But there's no relational key to say that there is one person across every table that was answering these questions. And finally, we have unstructured data, which refers to text, images, sound, videos, and artifacts that can be used for analysis, but may be more difficult to draw conclusions than compared to structured data. So I like to say that unstructured data is vast. It is everything else that is not structured or semi-structured. It is quite literally everything else that can be categorized as big data that doesn't fall neatly into one of these other types of big data. So unstructured data can be really helpful, but it can also be a little bit frustrating because it is more difficult to work with at the start in order to be able to draw meaningful conclusions about the information, because you have to spend such a large amount of time cleaning the data and really figuring out how it needs to be organized. So say you already have determined what type of data you have. The next step is figuring out how you're going to consume that big data, how you're going to work with it. And protocols and techniques are still developing for the use of big data. But at the moment, data visualization is perhaps the most commonly used tool for consuming big data. So, data visualization is a definition or is a term that we use as an illustrative snapshot of data. Really, data illustration refers to the ability to express something through drawing, photographing, illustrating, painting, graphing, or any other type of visual design. And data visualization really sort of like paves the way for statistics, because statistics is the framework that data visualization uses to digest information. So we use statistics to understand data, and once we understand data, we can then visualize it in a way that expresses what it means to other people. So statistics in the context of big data is the tool that we use for being able to display or visualize our results, if that makes sense. And that's one of the key things that we use when consuming big data, because we have these large data sets and they can be confusing to work with, but we use statistics to break it down into meaningful terms, and then we visualize it through data visualization so that we can make meaning of it. And data visualization is really this amazing tool that allows us so many benefits. Namely, data visualization allows us to look at the descriptive features of one single variable if we want. We can look at just one column of data visualization and say, okay, this is the conclusion that I can draw from it. But we can also use data visualization to look at the descriptive features including two variables simultaneously. So if you're looking at a pie chart and you have two variables that are included, you can look at how they are in relation to each other. But we can even get more extreme than that. We can go into 3, 4, 6, 10 variables all at once using data visualization. And data visualization also gives us the benefit of being able to see the relationships between two or more variables. So not just describing them, knowing the percentages of each, but also looking at how they are in relation to one another. And data visualization is a tool that gives us as researchers the ability to familiarize ourselves with the information in a data set and the ability to share this information with larger audiences. Data visualization gives us a way of conceptualizing the results or the conclusions that we're drawing about data, but then also it gives us the route for being able to explain that to other people, which is really cool. So, when you are processing big data, one of the things that we've learned, as I've already mentioned, is that traditional statistical analyses don't always work with big data because the data sets are just too large. And the entire idea of having data sets that are too large to work with in standardized analyses really paved the way for an entire field of statistical analysis that's called machine learning, or machines that learn. And the entire idea of having machines learn just like humans do comes from the revolutionary understanding that those machines are capable of making decisions, or at least suggesting decisions based on the data that is fed into them. So, machine learning, or machines that learn, are really our attempt to create computer analyses that can function like a human brain does, can take on new information, and from that new information, draw conclusions about what could possibly be going on in the same way that our brains work. We take in so much information in our day-to-day basis. Every sense that is going on in our lives, from sight, sound, touch, smell, taste, we are just getting overloaded with that information. And we as humans, our brain is taught what to pay attention to, what to listen to, what to attune to. And from that, we draw conclusions of how to act, how to move forward, how to behave. And the idea with machine learning is we want a statistics program that will have that ability. That ability to take in all of this information like a human brain does and then draw from it the important stuff. So the idea is that once a machine or a computer remembers the information that is given to it and understands the goals that are typically given to the computer in the form of written code that was created by a human, that machine can then make complex decisions and undertake complicated calculations to arrive at these decisions of where to go from here. And one of the things that sort of underlies machine learning is the idea of a schema. And a schema in this sense is a behavior that is repeated over and over, and every single time it is given the same reaction. We talk about schemas a lot in the context of human development with children, because in children, a schema is this, again, repeated behavior that when it is repeated over and over again, we can expect a child will do it again and again. Every time they see a pool, they're going to get very excited that they get to go swimming. Or every time they get to go outside, they know that they get to go to the park. It's this schema. Going outside means I get to go to the park because every time we go outside, I get to go to the park. And really, these schemas are the building blocks to intelligence in childhood. So in machine learning, we use schemas as the building blocks of this artificial intelligence. So the part that makes the machine learn. You're showing the machine this information over and over again, and every single time you're telling it, this is the outcome. This is what I want you to learn from this. And over time, that machine then establishes an association, which is the ability for the machine to make a connection between a new object and objects that it has never seen before or that it has seen before. So it's saying, okay, you've said that every time I see a picture of a cat, it is a cat. And you show me hundreds of pictures of cats. And then you show me a new picture. And I can say from that, based on the pictures, that this animal that has whiskers and 4 legs and a tail and short hair is likely a cat. So it has made an association. It's made a connection to say, I have learned what a cat is, and based on that, this new information that falls into the same sort of codes or decisions of what makes a cat means that what you're showing me is a cat. One of the things that machines also do is they use assimilation, which is the ability to process and identify and correctly categorize new objects by adjusting one's previous understanding. So once you have a machine that has an established schema and that is able to make associations between images, you can now almost create a variation in that and say, okay, now I'm going to start presenting you information that doesn't always fit the standard definition of whatever we're looking at. And I want you to figure out and tell me what it is. So an example of this might say, I'm going to show you a picture of a cat, but now this cat might not have a tail. Or this cat might not have all 4 legs, might not have whiskers. It might have long hair instead of short hair. And the assimilation occurs when the machine is able to process this information and expand or adjust their previous understanding. So the machine is able to say, okay, even though it's missing this characteristic, based on the codes that you have told me, this is still a cat because it meets these other qualifications. So it assimilates that information by expanding knowledge. And that is how the machine learns. And the goal of machine learning is to establish equilibration. And equilibration is a concept that explains the transition from assimilation to accommodation. So when an object is strange enough to not fit a previously known category, the machine, or even our brains, if we talk about this in the context of the human brain, gets confused and it is in a state of what we call disequilibrium. And once that object, that new object or event, is fitted into a newly adjusted category, the brain reaches equilibrium again, which is the goal. We want to get back to that equilibrium again because that is knowledge and that is how machine learning works. So, our book goes into great detail on the evolution of machine learning, descriptions of each of currently 6 major categories of machine learning, and how they work in a general sense. That information in our textbook is a little bit beyond what will be required for you to know on your licensing exam, so I'm not going to be covering it in our lecture. But if you are wanting to know more about machine learning, I am happy to chat with you during a synchronous office meeting or during a synchronous time so that I can talk more with you about machine learning because I'm happy to do that. But that is where we are going to pause the end of our lecture on chapter 15. And really, that's going to open the door for the next major assignment in our class, which is your course exam, which is due during week 7. So the exam will go live on the first day of week 7. So at 12 a.m. on Monday morning. So right at the first minute of Monday morning on week 7. And you will have that entire week of week 7 to take the exam. You can take the exam at any point during week 7 as long as your score is submitted before 11:59 p.m. on Sunday of week 7. So after 11:59 p.m. on Sunday of week 7, the exam will close and whatever highest score you have is the score that is recorded. So you need to make sure that you are happy with the grade that you have before 11:59 p.m. on Sunday of week 7. And the course exam will cover all the material that we covered through week 7 of our course, which means that it's going to cover everything from our textbook except for chapter 14, which we won't be covering until week 8. So you won't be tested on chapter 14, but everything else that we covered in lecture is included on the exam. The exam in total consists of 20 multiple choice questions and is open book and open note. So you will have access to your book, to your notes, to the lectures, whatever you want, as long as you are taking the exam by yourself. So you can take the exam with any resources that you need as long as you're taking it by yourself. Each question is worth 1 point, so you will have 20 minutes to complete the exam. And the exam will take place over 40 minutes. I know this slide says 30 minutes, but when you get on Canvas, it will be a 40-minute exam, which will give you 2 minutes for each question. And this will be updated in the slides that you have access to. I apologize that they're incorrect in this lecture, but you'll have 30 minutes to complete, or you'll have 40 minutes to complete the exam, which turns out to be 2 minutes for each question, which is probably not a ton of time to look up each question. So you still will want to have a pretty solid idea of how your notes are organized, study them a little bit, and know where to find information when you need it. The exam in total will be similar to the licensing exam that you will take for your LPC, in the sense that you will be allowed to retake the exam if you are unhappy with your score. The only caveat to that is, similar to the licensing exam, you won't be able to see which questions you answered correctly or incorrectly. You will only see your final score. So you'll see I got 10 out of 20 questions, or I got 11 out of 20, or I got 19 out of 20, whatever it is. That's similar to what you're going to see on the licensing exam. You're just going to get your total final score, and you're not going to be told which questions you got wrong, but you can retake the test as many times as you want. The key difference here is that on your licensing exam, there typically is a waiting period before you can retake the exam. For this class, you can retake the exam as many times as you want, as long as it falls within week 7. So keep in mind the retakes are only during week 7. And also similar to the licensing exam, you might not always see the same questions every time you retake the exam. Some of the questions will change between each retake of the exam. So you may see some of the content stays the same, but some of the content changes. So be prepared for that, both in terms of this class, but also in terms of your licensing exam. And as always, kick butt on the exam. I know you're going to do great. Reach out if you have questions. Again, I want this class to be an opportunity for you to learn what content you need to know for your licensing exam, where you can locate that information, and really, if a question is coming up and you know that you're getting it wrong every time, that's probably a pretty good indicator that you need to study that content a little bit more before you take your licensing exam, which is my whole goal with this course exam. I don't want this exam to be like the thing that tanks your grade in our class. I want this to be a good experience that leads you to a path that's going to prepare you for the licensing exam. So that is where we're going to wrap up our lecture on chapter 15. Good luck on the exam, kick butt as always, and I will see you all in the next lecture.